Okay, so before we start, some of you might have your quiz on Thursday, I think, because I got an email asking me to mark that quiz. So I suppose you have a quiz. Yeah, tomorrow. Oh, yeah, it's tomorrow. Yeah. So I'm marking this quiz. Hopefully you guys don't write too much. Anyway, quiz tomorrow. You had an assignment due as well, right? I think the quiz is substitution. Is it? Assignment is next Monday. I mean, you just had an assignment due, so I have so much marking. You need to mark your assignment, 236 assignment, and your quiz. So let me have a look at your quiz. See if there's anything I didn't cover. Linear equations and the substitution. Apparently, it includes concepts such as Bernoulli and homogeneous. Okay, I'm gonna do Bernoulli equation. Homogeneous for substitution. Yeah, we covered substitution last time, so hopefully it's okay. Let me have a look. How do you know which sub to take? Sometimes they'll tell you. Sometimes you have to recognize yourself. Yeah. I can't tell you what's on your quiz, but make sure you know substitution. That's all I'm gonna say. Okay. Yeah. So for today's tutorial, we'll do exact differential equation. That's the first topic, exact differential equation, and then we'll do Bernoulli equation, which is basically substitution. And then we'll talk about equilibrium solutions and stability, which is pretty simple as well. Your professor, I think she likes to make you draw stuff. No, I'm not talking about the quiz, I'm talking about your assignment. So make sure you know how to draw solution curves as well, okay? Which we talked about it before. So exact differential equation, this is just, so here is the definition for a differential equation of this form, where m is a function of x and y, n is another function of x and y, which is the factor of y prime. So if you see something like this equals to 0, if there exists a function such that the partial derivative of phi over x equals to mxy, and the partial derivative of y of this function equals to nxy, then this differential equation is called an exact differential equation. So we'll check, since we know that the partial derivative of x equals to this, partial derivative of y equals to this. So what you need to do to check if something is exact, you need to recognize your m and n, and then check if m with respect to y equals to n with respect to x. If they equal, yes, then it's a exact. Then it's exact differential equation. If no, then it's not. But no, then you might be able to find some other way to make it exact. Might have some other way. We'll talk about that later too. So you might need to multiply both sides by something to make it an exact function. I mean, not function, equation. Might have some other ways. All right, so let's do example 1. Did you guys cover this in lecture? I should have asked it first. Yes, okay, cool. So if the answer is yes, then that means you guys can do the question yourself. Okay, so I'll give you, I don't know, 2-3 minutes. Well, it depends on how fast you can do it. So I'll give you some time to work on this. And once you are done, what do we want to talk about this time? I feel like we did a lot of things. Favorite, which one do we want to say? How do we solve it? Oh, you need to find the function, the phi function. You need to find this function. So yeah, so you need to find this. How do you find this? Well, you know the partial derivative of this equals to this. So you know what this is, you can find this, right? Favorite drink? Sure, favorite drink. Okay, so after you're done with this question, let's talk about your favorite drink. Drink as alcohol or like non-alcohol? Because I'm going through the list in my head. Both? Either? Okay, cool. Oh, Wando, you finished the question already. I guess I'll start writing, and once you're done, we'll take it up. But I'll start writing first. Okay. Yeah, seems like you guys got it. Nice. So let's talk about it a bit. Let me see your favorite drink first. Apple juice, bubble tea. I'm not a big fan of apple, so I don't like apple juice either. I like orange juice and lemonade. Bubble tea, I like bubble tea. Iced water. I can't drink too much cold things, so Koid, okay. Jasmine boba or peach Bernoulli. Oh, I like peach Bernoulli. So good. I used to have like in a few bottles in my fridge. Subsistence, suffer cooler, water, iced water. Nice. They're so refreshing. Yeah, I know. Yeah. Let me think my favorite drink. My favorite alcohol is vodka. I just drink it directly without mixing with anything. Sometimes I mix it with orange juice. Yeah. Um I decided to quit alcohol because like I watched anime cells at work. No, orange vodka. Yeah. I watched Cells at Work. There's a Cells at Work Black, and the second episode was talking about alcohol. And after I watched that episode, I was like, okay, I'm gonna quit alcohol. So no vodka for me anymore. So now alcohol drink. Let me think. I like bubble tea. It's hard to pick. I think I like lemonade more. Tea latte. I like tea latte a lot. I like coffee too. My favorite coffee is cappuccino with whipped cream on top. But I have lactose intolerant, so it's gonna it's not good for me. But I just like it anyway. Okay, back to this question. So we take the partial derivative of m and n with respect to y and x respectively, and you get the same thing. So it means it's an exact equation, which means there exists 5xy such that 5x is m, 5y is n. And then you just take the integral of m or n, it doesn't matter which one, and you can get your phi. Notice that we have a function of y at the end. Okay? A lot of people will miss it, but you cannot miss it because here you're just taking partial derivative. You took partial derivative of x, you got m. So when you go back, you need to add a function of y, and then you take the partial derivative with respect to y and compare that with your n. You can find your h prime of y, and eventually you can find your h of y, and you can get the final result. Any question for this one? Should be pretty simple. How did you get plus c? Here, hy equals to a constant. H prime of y is 0, which means h of y is a constant. So, yeah. Yeah, any other question? Okay, if no question, here is the next part. Many times a differential equation it will not be exact, but we can modify it so that it's using integrating factor. So we can modify it using integrating factor and make it an exact solution, exact equation. So if we have something like this, we can multiply both sides by an unknown condition function mu f for xy. And then if this modified version is exact, then you need to check those instead of just m and n, because we're talking about the whole thing. Okay, if this becomes exact, then you can use the way we did before. So how do I find the integrating factor? If the integrating factor mu only depends on x, and R1 equals to this is a function of x only. So if you do this and find a function of x only, then you can use this. But if it gives you a function of x and y, then you cannot use it anymore. If the integrating factor only depends on y, and this is a function of x, of y only, I meant. Yeah, this is a typo, of y only. Then mu is given by this. So let's try example 2. So check if it's exact. If not, try use one of those to find your mu and use that to find your function. Hold on, let me think if here should be x or y. M is y. I think here should be y, here should be x. Or am I wrong? No. Here should be y. Well, one is x, one is y. I don't remember which one is which. If you try them, you should be able to figure it out. Yeah, I think this one is y.
I have a question.
Wait, I made a mistake, didn't I?
Okay.
An x. Wait, what did you say? How is n equals to y?
You said R1 is my minus nx over n, right?
Wait, say it again. I was really
You
low
said
in.
R1 is equal to my minus nx over n, right?
Yeah, yeah.
Then you said x plus 2y, which is my, then minus y, which is nx, over, it was supposed to be n, but you did nx.
Oh, I see. Yeah, sorry.
Yep.
X, y, plus 1. Yeah,
Yep.
x. Okay, 2y minus y. M is y, x plus y. So that's x plus y. X plus y cancel out, which is 1 over y. So we use R2. So mu goes to e to the negative 1 over y. D here should be dy. I feel like I have a few typo. Here should be dy. I'll fix it after I finish writing the question. here is y. Okay, x plus 1 over y prime. So this is new let's call it m prime. I don't know. M prime. It's not the derivative prime. It's just a new m. Now phi equals to this dx m prime equals to 1 over 2x squared plus xy plus h of y. And then phi of y equals to x plus h prime of y, which equals to x plus 1 over y. So h prime of y equals to 1 over y, and h of y equals to the y plus c. So we have 1 over 2x squared plus xy plus the y plus c equals to 0. Okay, that's it. So everything after here is same as above. Before, we just need to figure out which one do you need to use, and then after you used it, for example, here I checked R1 is not the one I need to use, so I need to use R2, and then find your mu, multiply both sides of the equation by mu, and that should give you an exact equation, and you just use a technique we did before. Now I need to fix the typo. Yeah, here should be dx and here should be dy. Okay. What happens if you can't use both R1 and R2? So there is another equation, it's called R3. I don't remember the equation, but there is another equation, which I don't remember. Yeah, but it happens very rarely. There is an R3, which I don't remember the equation. So look in the textbook and you might find the equation. But it's similar to this. I looked at your homework. I think she literally told you what your mu is. Yeah, she literally told you if you multiply by something, then you can get exact equation. So she doesn't even expect you to, yeah, she doesn't even expect you to find your mu, your like what I'm doing here. So I think she made your life much easier, right? Yeah. So I don't think she's really mean. Yeah. When I took the course, I took at St. George, we had at R3. So like the questions they suggested was all about R1 and R2, but the one on the test was R3. So yeah. Okay, next topic is Bernoulli equation. It's basically the same as before when we had, what do we have? We had substitution, right? Except you need to do extra steps. The definition here might look pretty ugly, but once we do the question, it should be pretty simple. Yeah, I think once we try the question, it should be pretty simple. So I'll give you some time to work on example 3. You guys did this in class, right? Bernoulli equation. Okay, so I'll give you some time to work on this, and I'll take it up. This time, what do we want to talk about? Remember, well, get your notes out and follow what they screw up, sure. Didn't I send you guys the worksheet? Do you need me to send it again? What do you like again? Although it has a few typos. Oh, okay. Fine. Alright, so this time, once you finished it, let's talk about your favorite drink. Favorite, do you guys read? We can talk about favorite book if you read. But I think at the moment, most people are too busy to read. What else do we have? Favorite course at UTM? Sure. Yeah, let's talk about that. Favorite course. Don't lie, okay? Let's be honest. Don't lie and tell me this course is your favorite course. I don't believe that. Yeah. So don't lie. Let's be honest with each other. I'll be back. Let's see. How many of you finished? Did you guys actually finish your question or you're just chatting with each other? Okay. It's okay. You can chat with each other. If it's easier, you can just unmute yourself and talk. Physics 147. I don't like physics. I like all sciences except physics. Bottom of the previous example. What else? Environment 100. I wanted to take that course, but just never had a chance. What's IMI? I guess that's writing 203. What is that about? Just writing essays? Writing, but real writing. What do you mean, real writing? Innovation and entrepreneurship. Okay. Oh, I see. I see. I think 102 is my favorite course at UTM. You feel awful after every class. Okay. 223 by far? I took 223 a long time ago. It's like 4 years ago. I really don't remember anything. 223 was a worst course. Wow. I don't like 232. When I apply for TA-ship, I literally put anything but 232. I absolutely hate that course. It's so boring. Okay, I don't like this course either, but I'm teaching it. 224 worst by far. I'm not a big fan of linear algebra, to be honest. Like, I like a lot of other math topics, but I don't enjoy linear algebra. But linear algebra is really important in math. It's used everywhere, so you can't really avoid it. Linear algebra, you cannot avoid it. The courses I took, like in upper years, most of them requires linear algebra. You just need to know it. Even that, I didn't enjoy it. Okay, enough chatting. Let's do this question first. I'll write, and you guys can continue chat. But I'm gonna write. Okay, so the first few steps is just setting up. Yeah, so set it up so that we can use substitution. Basically, we just need to divide something to make it substitution. What do you need to divide is right. It's not right here. You need to figure that out, actually. Yeah, you need to figure that out. But what do you need to substitute is right here. Okay, so let v equals to y to the 1 minus n, which is y to the 1 minus 4 over 3, which equals to y to the minus 1 over 3. Then my y equals to v to the negative 3, dy over dx equals to dy over dv times dv over dx, which equals to negative 3v to the power of negative 4 times dv over dx. So what we have is v to the power of 4 times negative 3v to the power of negative 4 times dv over dx plus 6 over x v equals to 3. So this will give you negative v prime plus 2 over x v equals to 1. So v prime minus 2 over x v equals to negative 1. And then you can use integrating factor. E to the negative 2 ln x equals to 1 over x squared. So this will give you 1 over x squared v prime equals to negative 1 over x squared. And take derivative on both sides. V equals to 1 over x plus c. So v equals to x plus c x squared. So y equals to v to the negative 3. So y equals to the whole thing to the negative 3. Okay, any question? No? Good? Wait, okay. Negative 3v dv dx. Okay? Where did the v come? It comes from here. It's you need to substitute your v back to the ODE. Yeah. Any other question? Okay, next, equilibrium solution stability. This is pretty simple. So we have a definition called autonomous differential equation. This is a differential equation which the independent variables does not explicitly occur. So something looks like this are called autonomous differential equation. So dy over dx equals to f of y. You don't have any independent variable on this side. So it's not f of yx. It's just f of y. So something like this, okay, is autonomous differential equation. And something like this, which has the independent variable t here, is not autonomous differential equation. And we have critical points, or called equilibrium points. I think your professor called it equilibrium points, so I will call it equilibrium points as well. So the equilibrium point is one. So if you have y prime equals to f of y, if yc equals to 0, so if this equals to 0, so for some c such that it equals to 0, then c is called the equilibrium point. So you just need to let this equal to 0 and calculate what is your y. If c is an equilibrium point to the autonomous differential equation, then ft equals to c is called an equilibrium solution to the differential equation. So, and we have those. Yeah. So we have symptomatically stable and unstable. So I think they just call it stable and unstable. Yeah. So suppose C is equilibrium point of the differential equation, and this is a equilibrium solution. Then there are two types of behavior. The first type is as t approaches infinity, y approaches c. So, for example, in this graph, this is c. As t goes to infinity, it approaches c. So in this case, that's the first case. The second case, as t goes to infinity, it moves away from c. For example, this one, okay? If 2 here is your c, as t goes to infinity, it moves away from 2. So in that case, that's the second case. So when it approaches to c, we call it stable or asymptotically stable. When it moves away from c, then we call it unstable. That's it. You don't think you took a lecture? You didn't get this far? Yeah, we didn't. Looks cool though. Okay, you didn't get this far. It's okay. It's pretty simple. I'll cover it anyway. So I guess we'll do 4 and 5 and 6. You can do it after your lecture. It's really simple, so you don't have to worry. Okay. So look at the example. Find the, let's call it equilibrium points. Find the equilibrium points and determine if they are stable. So you're given a graph. This is your function. So remember I said if dy over dx equals to 0, whatever your y is, that point is called your equilibrium point. So this is your equation. What is my equilibrium point? Anyone? Where did you get 1 over 2? The value of y. 0 is one of the, yeah. 0, 2, and 5. So those 3 points are equilibrium points, okay? So what you need to check is you need to check when y equals to 0, and as x goes to infinity, does your graph is approaching to 0 or going away from 0? So let's look at the graph. So 0 is here. Here is 0, so this line is 0. And as x goes to infinity, is it going approaching to 0 or going away from 0? Anyone? Is it stable or unstable? Going towards 0, yes. So since it's getting closer and closer to 0, we call it stable. So this point is a stable equilibrium point. Does that make sense? Simple? Easy? Yes, okay. So now let's check 2. So this is 2. So this 2. So this line is 2. Now tell me if 2 is stable or unstable. Unstable. Yeah, we're just classifying them. Yeah. They ask you to determine if they're stable. Exactly. A, B, C, D. Yeah. There are different solutions. Okay, so 2, y equals to 2, this is unstable. What about 5? Stable or unstable? Stable, exactly. Yeah, so you didn't cover it in class, but it doesn't matter. It's simple enough that you don't need to nerd from your professor, you can just nerd from me. Yeah, so that's it. And let's do example 5. 5 is pretty simple as well. So they ask you what are the unstable equilibrium solution to this ODE. So try this. So you need to first find your equilibrium solution, okay? And then you need to classify if they are stable or unstable. Well, well, even if you use it, it's not. You cannot put it on your exam. That does not count as final answer. Well, even if I say you're not allowed to use it, I don't think we can actually stop you from using it. No one has a camera in your home, so but you are not allowed to use it. I don't want to get fired. Anyway, so this is pretty simple, I think. So you need to find the equilibrium solution. Which is when y prime equals to 0. So that means y e to the y minus 9y over e to the y equals to 0. That means y times e to the y minus 9 equals to 0. So my equilibrium points are y equals to 0 or y equals to long 9. Now we need to decide if they are stable or unstable. Oh, there is another thing called semi-stable. It's a type of unstable. That's just one. So remember you have different solution curves. If one is approaching to it, the other one is going away from it, then you call it semi-stable. Does that make sense? I think it's pretty simple as well. So decide if they are stable or unstable. So what I'm gonna do is gonna write. So I'm gonna make a chart. Y, and now here is e y minus 9 and the y prime. I wanna see if they're going up or down. Here is, so it's like your 135 chart. Remember when you draw the graph in 135, you need to draw a chart, a table as well. So when it's greater than 9, y is positive. When it's between, y is positive. When it's lower, this is negative. And when it's greater than 9, long 9, it's positive, negative, negative. So this will be positive, negative, and positive. When it's positive, it means it's going up. When it's negative, it's going down. And when it's positive, it's going up. So if you look at this, you'll see that, well, at this equilibrium solution, you have one is going up, one is going down, so they are not approaching this. So this one is unstable. And when it's equals to 0, you have two approaching it, so this one is stable. That's one way of looking at this. Are we always meant to look at this line as the approach to infinity? Yeah, you always look at them as the approach to infinity. So the final, the unstable solution is just y equals to long 9. Okay? There are other ways to do it. So do the same thing, exactly the same thing. You can just draw a line, which is basically the same thing. Yeah, I'm not gonna do it. It's basically the same thing. So your professor might draw lines like this. Draw a line. And then here is 0, here is 9. And do the same thing, decide if they're positive or negative. If they're positive, so positive going this way, negative going this way. So that means this one is unstable. And the negative going, no, positive going this way. So two arrows going towards 0, that means this one is stable. It's basically the same thing, just two different graphs. No, I mean one is graph, one is table. It's really up to you which one you wanna. You wouldn't have to solve YT and show the limit. Well, sometimes you do. For simple cases like this, you don't. But sometimes if they give you something really ugly, then you have to use the limits. Okay. Any other question? Okay, then this is the end of the tutorial. Good luck on your quiz tomorrow if you have one. If you have a quiz next week, good luck as well. I think it's before our tutorial. And yeah, have a good week. No problem.